This lesson is about inorganic nomenclature. In particularly, we're just going to look at naming ions. Nomenclature is nothing more than a fancy name for naming things. We're going to start with cations, which mean positive ions. So cations are going to be ions formed from metallic elements. So we will find those on the left-hand side of the periodic table. Very simple. We simply add the word ion to the element name. For groups 1 and 2 that have a fixed oxidation number, we will have no problem because the location of the element tells us the charge. So sodium in group 1 would be Na+, simply sodium ion, while magnesium in group 2 would be Mg2+, for the magnesium ion. If you recall, we said that the transition metals could form multiple charges. So we have to have a system where we let people know which of the oxidation numbers we want to use. Roman numerals will be used to indicate the oxidation number. It simply equals the charge of the ion in question. So, a reminder that our transition part of the table is in groups 3 through 12, but we also find that the metals that come all the way up to the border of the staircase will also need Roman numerals, as they can have multiple charges. We're going to use iron and copper as an example to illustrate how we name and write the formula for these ions in the transition region. Iron can form a +3 or +2 ion. So that someone knows which one you want, you simply write the Roman numeral. So iron 3 ion, and Fe2+ would be iron 2 ion. Copper comes in a copper +1 or copper 2+. Therefore, we would name that as copper Roman numeral 1 ion and copper Roman numeral 2 ion. There are some elements in the transition region that only form ions of one oxidation number. We will use the original rule that says no Roman numeral needed to name these. The two that you must know and are responsible for remembering are zinc and silver ions. Zinc, Zn2+, has only one oxidation number, so no Roman numeral is needed, and we would call that the zinc ion. Similarly, Ag+ would be the silver ion. You must just memorize and remember these, as there's no indication when you find it on the periodic table to help you sort out that oxidation number. Now let's look at naming our anions, our negatively charged ions. Those are going to be from the nonmetal region, and we'll find that on the right side of the periodic table. We take the basic root of the element name and simply add IDE. So IDE indicates that we are looking at the nonmetal right side of the staircase. The group location will help us figure out the charge that goes with the ion. So chloride, root is for chlorine, is found in group 17, and so it has a -1 oxidation number, chloride ion. Oxygen in group 16 would have a -2 charge, so it would become the oxide ion. Similarly, phosphorus, which is in group 15, would form an ion phosphide ion, that would be 3 minus. If I wanted to write the formula for nitride ion, as soon as I see IDE, I know I want to look on the right side of the periodic table. I find N for nitrogen. The IDE tells me it's an ion, negatively charged. It's in group 15, so I would have a -3 for its oxidation number. The last group of ions are known as polyatomic ions. Unfortunately, these require some memorization, but a couple guidelines will help us simplify it a bit. Poly means many atoms, so these are groups of atoms that collectively have gained or lost electrons. Think of them as little gangs. There are 17 that I am asking you to know, and you can find those on page 53 in your textbook. The helpful hint for memorizing those that end in ATE and ITE is noting that the ATE form always has one more oxygen than its companion that ends in ITE. For example, sulfate you simply must remember is SO4 2-. However, if I want to write the sulfite ion, I would take one oxygen away, so it would become SO3 2-, and I would write sulfite ion. The charge stays the same. So for chlorate, ClO3 -1, I simply have to remember the formula and the charge, but once I know chlorate is ClO3-, chlorite would simply have one less oxygen, ClO2-. So if I told you phosphate was PO4 3-, the phosphate ion, you would be able to tell me that the phosphite ion would have a formula of PO3 3-, one less oxygen than the phosphate form, but the same charge. So that ends naming ions, and we'll see how being able to name our ions will simplify writing names and formulas for ionic compounds.